All right, so here we go. We've divided this into 3 parts: pressure, temperature, and volume. Okay? So the very first thing, back from the starter, we just went over what these 3 things are. So that's the first thing we're going to do. We're going to define those 3 things kind of in our own words, kind of scientific, mixing those 3 things up. So let's look at this. Pressure. What did we say pressure was? It's a force, right? So I'm going to put the definition. I'm just going to use little stars. You can use little bullets if you want to. So pressure is a force of what? What's causing that force? Okay, so it's measured in atmospheres. Particles, that's right. So it's a force of particles. And what are those particles doing in the gas? They're moving around and they're bouncing around, right? So it's the force of the particles bouncing. And that bouncing around, when they collide with other particles and they collide with the edges or the walls of that container, it creates that pressure. Okay? Now, over here, temperature. What did we say temperature was? We kind of worked our way around and we talked about it. What's temperature?
Down 7. A measure of the average.
Okay, it measures the average. What did we say? The average what? Kinetic energy. I'm going to abbreviate KE for kinetic energy. We've been in physical science long enough. If you don't know KE means kinetic energy, you write out those words, kinetic energy. And again, just to recap, kinetic energy is the energy of motion, or is it stored? Motion. Kinetic is always about something moving. All right, over here, the volume. What did we say the volume was? The space. Look at that remote. The space that does what?
That matter takes up.
That matter takes up, that matter occupies, whatever you want to say, that takes up. Right there. Because these are your notes, okay? You need to write them in kind of your language, so when you go back to study, that you got it and you're like, oh yeah, I remember that. Okay? Now, next thing we're going to do is we're going to write the SI units of measure for each one. So pressure is measured in what SI unit? ATMs, which stands for atmospheres. I'm just going to write the abbreviation. I'm okay with that. These are your notes because you have the actual word in your reading. You have it in your notes as well. And what's the temperature SI unit? I can't hear you. Say it again.
Temperature is measured in what?
Degrees Celsius. And I'm just going to abbreviate that. Again, we use Fahrenheit, but Fahrenheit is not scientific. Fahrenheit is a customary unit. And then volume, and our volume for our gases is measured in what's volume? What's the unit of liters? Thank you. Liters. All right? So the next thing that we're going to do, that's okay. The next thing that we're going to do is we are going to look at their relationships. So that little chart that had all those little arrows on it, we're going to get that out, or you're going to have that out just to look at, okay? Have that out just to look at. And we're going to compare. Now I'm going to use some abbreviations on this chart, okay? And then this is going to summarize it. So I'm going to compare the pressure to the temperature, and I put P to T, okay? And then I'm also gonna compare the pressure to the volume. So, and I'm gonna put these little equal signs down here, and this is my little shorthand. So I'm comparing pressure to temperature and pressure to volume. Of course, if I'm comparing pressure to temperature, what's the volume doing? If I'm comparing pressure to temperature, look at your chart and tell me what the volume is doing.
One of them has to be what? Who said that?
Somebody said it. I heard it. Ooh. That's right. 2 for 2. So we've got constant, right? So if you're comparing pressure and temperature, the volume's constant. What if I'm comparing pressure and volume? What's the temperature doing? Constant again, that's right. So if I look right here, pressure to temperature, look on your chart and find the one where your volume's constant and you've got arrows in pressure and temperature. And tell me what those arrows are doing. Are they going the same direction or are they going opposite directions? Same direction, right? So if the pressure goes up, the temperature goes up. If the pressure goes down, the temperature goes down. And you know what we call those relationships if they're the same? Does anybody know? All right, these are directly related or directly proportional. So I'm going to say these are directly related. That means that they're the same. If you don't know that that means the same, but this is the science word they're going to use when they ask questions. They're not going to say, are they the same? They're going to say, are they directly related? Is there a direct relationship there? Whatever. They're going to try to sound real scientific, right? Right? I'm telling you, it's just words. People use words to try to sound smart all the time. All right. Pressure and volume. Are they the same or are they opposite? They're opposite. Now, opposite is a word we use in middle and elementary. So does anybody know when you have an opposite relationship what they're called? Inverses, right? So these are inversely related. Okay? Now, we're going to do the same thing with temperature. So for temperature, we're going to compare temperature to the pressure, and we're going to compare temperature to the volume. So if I'm comparing temperature to pressure, what's the volume doing? Staying what? If I'm comparing temperature to pressure, and they're the things that are changing, they're my variables, what is volume doing? It's staying constant. That's right. And so if I'm comparing temperature to volume, then my pressure is staying constant. All right, so looking at your chart, let's look at the one that your temperature and pressure are related. And if you don't have to look far, because we just made that same relationship comparison over here. So are they directly related or inversely related? They are directly related. They are the same. So I'm just going to put direct. Now what about temperature to volume? They are also direct. Good. So you notice anytime I have temperature involved, it's always the same. So if they're comparing anything to the temperature, it's going to have the same relationship. It's going to be a direct relationship. Yes?
Direct is where they're both going in the same direction. Okay. If one goes up, the other goes up.
That's right. If one goes down, the other goes down. Inverses are opposites. One goes up, one goes down. Okay? All right, so let's look at the volume. So we're going to compare the volume to the temperature, which we've already done, and we're going to compare the volume to the pressure. Guess what? We've already done that over here too. Okay? So let's look here. Volume to temperature. What's that relationship? Direct or inverse? Direct. Again, anytime you compare to temperature, it's going to be the same because temperature changes the same way the pressure changes and temperature changes the same way volume changes. What about volume to pressure? We already did that over here. They are inverses. So if I look right here, if I compare my volume to pressure over here, that's the same comparison as it is over here, pressure to volume, right? It's the same comparison. So there are only two inverse comparisons here, and they're the same things, right? One way that I remember it, you may think it's hokey or stupid or whatever, but usually the more stupid stuff is, then the more it sticks in your brain, like that King Henry died Monday drinking chocolate milk or whatever you remember. You know, stuff like that that's silly, those mnemonic devices. What I use to think about this for the metric is I remember VIP. Because these gas laws are named, VIP means very important person, right? Somebody's a VIP, very important people. All of our gas laws are apparently named about very important people. I can't tell you. I'm sure in their time they were very important. And so apparently they're very important because their names in textbooks and they have laws named after them. But VIP can also stand for the only inversely proportional relationship that is there. Volume is an inverse of pressure. Volume is inverse to pressure. Everything else is the same. Everything else is a direct relationship. Pressure and temperature is direct. Volume and temperature is direct. But volume and pressure are inverses. If that helps you remember. Though if you can remember this, you only have to remember one thing as compared to 12 different comparisons and try to memorize all those arrows. Does that make sense? A little bit? All right, so those are 3-hole punch. Put those in your notebook.